all the stuff what we are supposed to finish. And okay, so I think that the goal of our course is to cover all these 10 modules, basically 9 modules, but the 10th one is more of like looking at some of the business scenarios and case studies, specific cases, and work on one case study with the real-time data we have. It's also available already as part of our labs. So that, but just to recap what all we really learned and what we should continue to uh, do more exploration in these areas. AWS essentials, that is the core piece, which has to be whatever we learned is the basic, but we have to get more hold on this, like whatever we are learning, whatever we are using as part of essentials. A lot of AWS services we are using as part of the solutions, so has to be, we need to be more robust on that. And big data and Hadoop essential, this is a very basic and very important. Without these fundamentals, any work we do, it's not going to add value for users. And Amazon DynamoDB, the NoSQL database, is a key component in the Hadoop world also. Like, whether you use DynamoDB or MongoDB, doesn't matter. NoSQL database has a significant role in the Hadoop solutions. And big data storage solutions, so many ways of doing big data storage solutions. It's not only Hadoop is the solution for big data storage, and especially with Amazon stack, it is like there are so many ways you can do big data storage. And solutions wise, we looked at all of them. And one of the option is Amazon EMR, which we explored a little deep, and tried to do, understand how the ingestion compression works and storing and processing methods. And then we extended our learning into Kinesis streams and Spark streaming, which is more meant for real-time data processing and analytics area, in addition to batch, that can happen, ingestion and all that. And we also extended our learning to Kinesis Firehose, which is mainly meant for, again, Kinesis is having multiple components: Kinesis streams, Kinesis Firehose, Kinesis analytics. It's all related to basically streaming data and real-time needs, basically. And then we also learned about IoT, how the IoT can actually, IoT means like it's not just as one of the IoT source, like how IoT devices can be controlled, or the data can be processed and control the devices itself. So we looked at those exercise, and we looked at Amazon Redshift as a data warehouse solution for big data on Amazon stack, for regular reporting and other needs, in addition to the analytics, right? And also we looked at the deep into machine learning area, how Amazon machine learning specifically works. And we also looked at how to visualize all these big data, whatever we store with whatever solution on Amazon, how we actually visualize using Tableau as the recent thing that we did. And it doesn't need to be Tableau. It could be QuickSight. It could be existing ClickView, or a lot of existing Cognos or Oracle. It could be any type of, because everything has plugins now to be able to leverage big data platforms as a source. So I think with that, like, it gives you a very good spectrum of all the components required to be successful big data analytics professional on AWS platform. I mean, not only AWS, in general, some of the concepts we learned, it could be anywhere, but we focused our course mainly to use AWS as platform, because a lot of companies moving towards that in terms of cost optimizations and general cloud strategy point of view. So, and today we come down to the last module here to look at various business scenarios and case studies that are happened in the real time, and how some of the organizations are using these solutions, especially big data analytics on Amazon platform. And the case study that we are going to look at is one of the architecture using how machine learning and I see those two are like two important components that are very useful in terms of
Hello?
will give you more
Yes, Sugaru.
value, because most of the solutions are
Maybe.
happening in this direction.
So your voice is breaking sometimes.
Voice is breaking?
It's fine, but somehow I don't know whether others feel or. Mr. Gavin?
Is it better now, or maybe my
No,
headset?
it's better. Yeah.
Okay, maybe my headset itself. Okay. So I mean that's the overall the plan for our course, and we are coming to the tail end now, and let's switch the gears to the last topic here and see. And again, at the end of this, one thing I will do is I will send out some of the emails that can help you to look at certification. I know how to certify, get basically there are three levels of certification in Amazon side, right? On AWS, it's called associate, and then professional, and then specialty. So ideally what we are learning is more of a specialty for big data analytics on Amazon. But if you want to really get certified, these are the prerequisites. You got to get and then you can become professional or specialized, and you can become to be both. Associate, you learn to do all three in one specific area. Again, one specific area means like in the solution architecture side, or as a developer person, or like more like a DevOps, or like operations side of things. So instead of operations or developer side, I would prefer architecture side, because most of the AWS solutions prefer DevOps, not just Dev. Architecture, if you go through the architect route as an just associate and professional and specialty, you cover like more DevOps, which is more useful, and really that is what make you more valuable for the market.
Hello.
Yeah.
Your voice is breaking, Andy.
Yeah, same here. అది నాకు కూడా అనిపించింది.
One second, let me see.
లేదండి ఇప్పుడు కాదు, మళ్ళీ sometimes intermittently. It's intermittent.
Maybe it's my
network or
maybe my network. Maybe
or
one
this
second.
Yahoo,
Generally,
Google
it's better here down. I can't. Your voice also breaking for me actually. Not sure if the overall connection is good or not.
No, చూడండి, పింగ్ చేయండి, మీరు పింగ్ చేయండి. మన ఇంటర్నెట్ లేటెన్సీ అని ఉందా మీ దాంట్లో?
The speed, right? Yeah.
Yeah, ping or what do you call that? Timeout, right? What is the latency? Pingcisco.com.
No, there's a. You want to check the speed, right? So.
Oh, there is a. Like my internet చూడొచ్చు మీరు. What is my internet speed? Google లో.
Yeah.
దాని బదులు latency తెలుస్తుంది. Latency తో తెలుసు క్లియర్గా.
Definitely some latency, because your voice also is giving some lag for me. So it's maybe in both ways actually. What is this optimum? No, not optimum. There's a speed. There's some tool actually. What is that?
Speedtest.net.
There are a lot of tools actually. Speedtest.net. Okay.
నాకు 10 milliseconds, 9 milliseconds, 10 milliseconds, 10 milliseconds సార్ నా పింగ్. మీదంతా చూడండి ఒకసారి.
Yeah, I'm checking in.
Oh, I didn't know that they have speed test.
Yeah, definitely slow, I think.
Yeah, let me do same thing. I didn't know that there is a.
Yeah. No, maybe if I restart, it might come back better.
Yeah, you're right అండి.
Yeah, no, this is not good. I think it's
I,
definitely
I, yeah, for me it is
not
fast.
something.
For you, మీద అన్నట్టు మీ దానికి రాన్న కూడా రావట్లేదు. నాది ఫాస్ట్గా ఉంది, నాది ఫాస్ట్గా వచ్చేస్తుంది.
Yeah. No, it is actually trying. This is not even connecting to that. So let me do.
ఒకసారి రిఫ్రెష్ చేయండి కేశవ్ గారు.
సార్ అలా కాదన్నా, కేశవ గారు మీరు పింగ్ చేయండి ఒకసారి, నాకు నేను చెప్తాను కదా, మీరు పింగ్ చేసి cisco.com కొట్టండి ఒకసారి, మీకు తెలిసిపోతుంది క్లియర్గా. పింగ్ అవుతుందా టైం కూడా వస్తుంది.
ఏది పింగ్ చేయమంటారు?
మీరు కమాండ్ ప్రాంప్ట్కి వెళ్ళి www.cisco.com
Cisco, okay.
కమాండ్ ప్రాంప్ట్కి వెళ్ళి పింగ్ cisco.com. అక్కడ కాదండి,
కమాండ్ ప్రాంప్ట్ మీదండి.
మీకు లేటెన్సీ తెలిసిపోతుంది. ఈ పింగ్ cisco.com www.cisco.com. మీకు 65 milliseconds అండి, చాలా లేటెన్సీ అండి, అది మాక్సిమం less than 10 ఉండాలి.
Yeah, 65 milliseconds, right? Yeah.
రిక్వెస్ట్ టైం కూడా వస్తుంది చూసారా, మధ్యలో డ్రాప్ అవుతుంది.
Right. Yeah. So it's definitely slow. Yeah. So let me do one thing, and I'll just restart my connection also. So, but I may drop and connect again. If the link is changed, then I'll resend the link in the email. Just give me a couple of minutes.
Okay.
Restart this mostly.
పింగ్ నాకు 20 milliseconds.
Can you hear me still?
Yeah. పింగ్ 20 milliseconds వస్తుంది.
You can still hear me, right?
Yeah.
Okay. But still, it is not better. Let me restart, and I'll restart the machine itself, because I don't know if something may be hanging or eating some bandwidth. Yeah. Hello? Can you hear me now?
Yeah, we can end.
Perfect. Yeah. So is it better now or still there? Is it any better or? Okay.
Don't know actually. Like it's not
Not bad.
always. Yeah, it's breaking in the middle, not like completely dropping.
Yeah, let's try for a few minutes and see if it is really bad. Then maybe I have to reset my router itself. But otherwise, let's see if it is too bad. Okay.
Or else try connecting with the LAN, and so you'll be having the Ethernet direct connection, right?
Yeah. I right now, because I'm not close to the router, but let me do that. That's the next step. Actually, I wanted to reset because usually my network is very good here. At least by this time, it should be nobody else will be using anyway. So, okay. So, okay, as I told, today we'll focus on the case studies, and let me try go there. Yeah. So before we jump into a particular case study, let's quickly take a look at a couple of case studies that were done using Amazon platform. They are in the real use cases. So in general, right, what are the use cases that generally people try to do? These are very common use cases. So predictive analytics is one thing. For the reason of predictive analytics, people go to big data platforms, that which is basically to capture the current data and efficiently analyze, use historical market data to do the predictive analytics. This is where you do mostly the machine learning as well. And the trend analysis, so which has to to examine the trends over the period of time by month over month, year over year. Sometimes if it is a real time, like every hour or hour, also or day by day or like that. And the recommendation engine. This is what we did in Bank of America, my project at least. The recommendation engine mainly, uh, you know, to recommend. We used to have analysts who publish the research documents to predict basically what is good, or to buy or sell the market in the stock market, and the clients who are actually buying stocks or selling stocks based on our
Oh,
analyst
sorry.
research. Hello.
No, I thought you were sending the new link and I was waiting for the typing in the WhatsApp forum.
Oh, okay. You're able to hear now? This is the same
Yeah.
thing actually. Yeah, sorry. Because it came back to the same regime. I was able to resume the same session. So, yeah, I just started talking about some of the use cases that people use in the industry. So the predictive analytics and trend analysis, the recommendation engine, which I am giving some example what we did for Bank of America project. And the recommendation engine, what we did is we have research analysts who are publishing documents about certain company tickers and stocks, what is good for buy or sell, that type of the analysis. And based on that, our clients buying or selling stocks. And but what we created is a recommendation engine. That basically recommendation engine is to predict what our clients are showing interest or researching. Like, let's say we publish some documents, and clients may be doing their own research on looking at various documents that are published by various analysts. And based on those documents, what they're looking at and what they're showing interest, so we have a recommendation engine that can predict what clients' interest is and what they're looking for next. So based on that, we can proactively reach out to them and make recommendations. Not only just based on the analysis of stocks analysis, but our research analysts produce, and also combining that with what clients are looking at. So this is proactive recommendations. And risk management, this is another very important use case for most of the financial sector companies. Not only financial, actually, this everywhere. The risk management is the most important piece. The merger and acquisitions, where you need a lot of fast integration, all the data related to merging companies, because you cannot do mergers for like 3 years, 4 years like that. When merger happened, still, let's say Bank of America Merrill Lynch merged, customers don't wait for you to do the merging transition for like 3 years, 4 years. The operations has to go on, and they want a single view of all their data across the companies. So all the data fast integration has to happen. So even in these cases, this will help a lot. So these are some typical use cases, and you can pick so many specific use cases out of these business scenarios. I would call them as business scenarios, but if you take a look at like by industry, these are at a very higher level. Like if you look at media advertising, or oil and gas, retail, or consumer health, or security, social media, these are other areas where by industry, if you take what they look for, right? In media advertising, mostly they look for targeted advertising or image and video processing. And the oil and gas industry, they look for gas meters and pipeline sensors. It's more like IoT related things comes here. And the retail area, it's again recommendations, transactional analysis. Consumer health, it comes with biosensors and clinical analytics. Here also a lot of IoT stuff happening. And security, antivirus and fraud detection, image recognition, all this comes under more security related risk management type of thing. The social media, gaming, demographics, usage analysis, in-game metrics. So these are all like various ways of looking at business use cases. Okay, here is one specific example or scenario that I worked with, when I worked with Bank of America Merrill Lynch, that I was explaining earlier. I mean, I don't want to mention the client name or what we did and all, but this is at a higher level. I try to put some inputs here, what we did exactly, and this could help, in other scenarios also. So problem definition we had when we started this project, we have a vast amount of sales data coming into our data warehouse, which is in Netija at the time, and we need to process weblogs to know the habits of clients. That's a new type of data set coming to us. So far, always we had sales data, and which are all like more of a database sources. But when it comes to weblog, we have a clickstream weblog started. Those habits of clients, it's like a gold mine of data, which is never tied to our standard sales data. So we have a need to tie that data, weblog data, which is more like a semi-structured data, not really unstructured, but it's more of a big data characteristic little bit. So our existing data warehouse doesn't support all these type of things. So we started, because when I say weblog, not only just weblog from the websites, we also had feeds like Bloomberg feed, which is a terminal, like a Twitter type of a short chat message type of things. So we had to get various type of data sources which are not traditionally part of our sales data warehouse at the time. So we've come up with a solution using Hadoop and Big Data Platform. And the main use cases we try to solve there: recommendation engine and trend analysis. So those are the two main use cases we try to address. Okay. So the solution, how we provided, I mean, basically this is a very like a high level flow.
Yeah, sorry.
Tell me, sir.
Can I ask some questions, or you want to continue?
Yeah, please. No, please go ahead, because as it's all contextual, right? So you better ask as and then. Yeah.
What was just I want to understand what are the weblogs? This is
the weblogs is basically, yeah. So
let me complete it. Weblogs ante you have given a web-based application to the client where they log in, then they will start doing the research analysis.
Yeah, basically we used to have something called research hub. What that means, it is not only Bank of America Merrill Lynch analysts publishing the documents, research documents, and it could be any star analyst in the market, Wall Street. publishing documents into that research hub, which is like a common research analyst documents can be published in that area. It's not only just our analysts, but our analysts also, like just like it could be Goldman or JP, or it could be from any Wall Street company. All the star analysts will be publishing their documents, and they have ratings based on the usage of the data, as well as how much how much of their accuracy of their analysis and all that. So they get rankings also, right? Wall Street rankings, right? Analysts. So what this website, what we had was that research hub, which is not owned by Bank of America. Okay, but we do have our documents published, and other documents also published by other companies and other analysts. So we wanted to generally track what companies, let's say Fidelity is investing some some $100 million whatever on some, right, and for that month, or for that investment particular period, and where they are trying to put their money. And they do mostly go by the sales sales pitch mostly, right? Because every company has their sales pitch, and then generally they take certain percentages. For example, let's say they decide to do 30% for Bank of America, 30% for Goldman, 30% for JP, or 30% for something else, right? So they do all that, but they still left with like some 10%, 20% they do on their own analysis to do it. That's a competitive edge basically, right? That the leftover pie of that piece, they do by doing their own research, which they will go to not only just Bank of America published documents. So they go to this common website, and so we need to find that information is very useful, what they are looking for and what documents they're reading and which analyst recommendation they are following, all that. So we try to collect that weblogs data from that research hub, which is external to our site. Okay, that's as a source. So we can find, basically, as I explained earlier, what we are collecting, the habits of clients, because they could be clicking on that website not only page level, in each section, in each keyword there could be multiple things happening, and there will be clicking on multiple. So let's say they might click on for example IBM stock, for example, on while they are in the session, how many times they might have clicked and come back to that review again and again, do more deep analysis. So you will know how long they spend time, and a lot of information has to be known, right? A lot of that information we never really collected. Even if we collect, it is in a silo, it is never integrated with our sales data, because there is no a proper platform to link all of this information. Does that make it clear to you?
Yeah, that makes clear. In FXall, we have the system, and FXall is a system, FX trading system, which is used by all these buy-side companies,
right?
Like hedge funds and mutual funds.
Right.
We even JP Morgan also go there. They request for quote and different brokers,
right.
And we find out the what is what customer is trying to do, what quote he's requesting, what is the research he's doing.
Right.
What is the data he's
yeah, that's on the fixed income side. Yeah, the one I mean, this we focused on more equity side, but because that has a lot of volume, right? I mean, volume means like the transactions are small, but volume is bigger. I mean, fixed is always like volume is high, low, but transactions are big, the value. So yeah, so I mean, basically, I think we do have it's a similar platform basically. I didn't remember. We also published for the fixed side also. So that's exactly. I mean, basically that is one input, but later on we added a lot of other sources. But we started with that as a use case first, because later on we got actually Bloomberg terminal feed also, like what they're chatting with our salespeople. Like sometimes they may not really read the documents, but they may be chatting about something with our salespeople or traders. Okay, so basically we married the regular sales data warehouse data with weblogs in the big data platform, and come out with the recommendation engine and trend analysis, alerting, and prediction and forecasting. and also we provided analytics and data visualization on that. So these are all done using this layout at that point. We used actually Cloudera at the time because that was the one, initially that's the only product actually officially more robust, or maybe more started initially. More reliable, I would say. So we used a two-way, like a hybrid architecture here. So we don't want to change what things are there on data warehouse, because it's a huge data warehouse and a lot of things are already happening, a lot of recommendations and analytics already. So we left data warehouse as it is, but we created a new feed, weblogs feed, which is more like a big data category, also to go into data warehouse as well as come into the Hadoop platform. But anything new, we wanted to only, initially we thought we will only put it into Hadoop, no need to put it into data warehouse. But we also see a need to go into data warehouse for some short-term gains while we are building this. Okay, so we put both. And eventually what happened, all the data coming from data warehouse is through the scoop engine, which is basically ETL type of thing, and weblog directly coming, and then it's getting processed. And we use the regular map reduce at the time, because now we have a lot of options, but at that time we don't have streaming, and I mean we have, but not matured enough. So we mostly, this is anyway more like a not really real time. We went for a big data platform mainly for two reasons. One, because this data source is like a big data type of data, and the second one is the volume of data we are dealing is like our Netija warehouse was not enough capable of, scalable enough to hold all the data we are collecting. Already it is on the top of edge of the capabilities of infrastructure scalability. So we thought the future is only with this. So okay, so that's the sample architecture, and one specific use case what I worked on, but I worked on like at least multiple use cases, but I just put one to give a quick brief there. And really, that is again what I showed is nothing to do with AWS. We did with Cloudera, right, which is a Hadoop platform. Now, if you look at the AWS in the market scenario, ML-BAM, you must be knowing this. Most of you already know this. This is mostly like a gaming one, which is a game means like a, I mean, in US, right? I mean, you have all these
baseball.
Yeah, I mean, baseball and basketball. A lot of, most of the clients like sports in the sports area use big data heavily, because their the needs of their data needs are like really big data characteristics. So the volume point of view and velocity point of view. So most of the people are using, but this particular one is using AWS platform to do their way they build this to track the system. Like it's basically a nuclear tracking system using power of big data analytics. And I mean, you will be able to use this video, but this all available. You can use this. I'll send these links to you anyway. You can watch separately, but it'll be amazing to see how they're using it, the power of the AWS. But to give you a glimpse of what it is really doing, they're heavily using the high-level services to trigger the like Lambda Kinesis in the more real-time model, and they're also using S3 and CloudFront, and they're using a lot of data coming at the same time, and a lot of processes that have kick off in parallel. Kinesis is a great single job process. So basically, it's like a streaming data, you can call it as. That's the reason why they went for this. And what really it is doing, okay, they have players, umpires, and the ball moving around, and they track that the stereoscopic machine vision and radar. The combination of those is gathered and assembled at the ballpark and then sent it to the AWS cloud for processing. And the arithmetic of data points flowing around the field, turning into things like a home run or route efficiency, all efficiency. So if you see a lot of analysis happening live, right, when the game is happening. So how that all happening at the real-time analytics is by capturing all these data points around the field. So which is very lively and very more interactive analytics. You will see right there, like when the game is happening. So this is one of the awesome, one of the very interesting use case that in the sports area, I mean, especially in the games entertainment area. And so if you see the case study, what they did, right? They have basically why they went for this one, because they wanted to scale up and down quickly to handle the data on gameplays. Because not always you need that capacity, right? So you need high capacity when the game is happening, and you don't need that much when you don't have a game. So they can easily scale up and scale down. So all that. And also the reason why they need this, because they have to store at least 17 plus petabytes, not terabytes. Okay, 17 plus petabytes, and no such storage solution better than AWS for this type of data. So I mean, any Hadoop is good, but especially because they want to ramp up, ramp down easily, so they need cloud. So that's why AWS is the natural choice. And it needs to happen in within 12 seconds to capture, analyze, and deliver the analysis on air. So it's a timing is very important. It cannot be slow. It has to be like supersonic speed. So volume and speed, those are the two characteristics of big data made this as a choice. Okay. So yeah, I mean, since we have limited time, I'm not playing this YouTube thing, but I'll send these links for you also. You can watch. All this will be there on YouTube anyway. If you just search, also you'll get it. And the other important use case, this is the most ideal use case, AWS market. And if you go to Amazon, everyone will talk about Netflix. The reason for that, Netflix is the only company that knows, or maybe so far, who know how efficiently use AWS infrastructure, how maximum potential they can take advantage of the AWS infrastructure, cloud infrastructure. Netflix is using ultimately, no customer was able to use that efficiently and that effectively all the capabilities and services that Amazon offering. Okay, and very, very effectively and very efficiently, cost effective as well as more, performance point of view as well. And why that's why Netflix is actually Amazon, a lot of services built because of Netflix, because Netflix like a client that gives them requirement. I need this is not, I'm not able to do this, I'm not able to. So they create products because of Netflix, and that they make it as a product for all other customers. That's that much important Netflix customer for them. Okay, and why it is, because it's mainly a lot of content, like a video, as movies and all this stuff, and it's a heavy storage first of all, like in the petabytes. And if you see here, it needs the flexible IT infrastructure to experiment, analyze, and grow its business worldwide. And it measure their user streaming experiences through the analytics platform, because they have to measure very closely what user experiences is, because that matters for them for the business model. And they have to deliver billions of hours of content monthly, which is going to take so much cost. So they have to find a best platform for that. And it operates with the 10 petabyte data warehouse, with the S3 comprised a lot of objects there. So yeah, basically all the standard needs, but Netflix is really using very efficiently. The Vivaki, this is another very interesting case. I mean, it may not be that popular as the other two I mentioned, but this also, here it needs to process large amounts of data quickly, because they have campaigns like the digital ad campaigns. This is more of like campaigning type of company. So for the digital ad campaigns, they use large amount of data they need to process. So, but they need a lot of sources. Here it's a variety. The big data has three characteristics, right? It could be because of volume, or it could be because of velocity, it could be because of variety of the data. So here there is a multiple variety of source of data comes from various ad agencies, because they have to collect this information from various ad agencies, which could be in very disparate type of sources. You cannot ask them, okay, give me data only in Oracle or give me only in SQL Server. Whatever the data they have from any agency, they should be able to process it. That's a use case there. And they develop their own suite of products for data management, and they reduce their operating expense by 75%. compared to what their on-prem solution. So, I mean, this is to showcase how much of savings you could do compared to on-premise versus AWS cloud. This is what they showcase, because the cost saving wise, I mean, they say generally like, there is at least 1/10 of cost saving, but 75% is insane. So they are able, some companies are able to do that. And the weather company, this is another very, very interesting case, because weather is like one of the biggest, like we get so much data from satellites. The weather company collects, like, that's how we have all the so much of information collected continuously. So it has to ingest, store, and analyze so much data. They're saying 4 gig per second from 800 sources. Okay, so it has to be mapped and processed into forecast points, and in a real time. So naturally, they went for S3. Amazon services, and S3 is the key in their storage. And they also use Amazon Redshift for the powered analytics. So this is another biggest use case. So if you see in the bottom, they're saying they use AWS and TWC, which is a weather company, designed its platform to handle more than 15 billion API calls each day at a rate of 150,000 per second. So it's unimaginable rates of access rates, right? I mean, if you see what type of things it is handling in a real scenario. So that's pretty much, I mean, now again, these are the reason I showed some of these use cases and case studies, to have a feel of what it is doing and how clients are using it. And that means the power is enormous, but how you use and for what purpose you're using, it makes a lot of difference. So learning all the technology is one side, and in what scenarios, in what then what technologies we have to use, and making a decision and using it in an efficient way is another step. So now that will lead us to take one particular use case, and we can analyze detail right now. Maybe I hope we have another 1 hour at least, right? 9:30. Yeah. So if you guys are okay till 10:30, then we can really go through step by step of one use case, and which is a real data, which is more of a air traffic, which is it's a public data set, but it is a air traffic related use case from I'll show. Actually, I think it's from one of the airport authority or some the public data. It's provided, it's available. You could also download anywhere, and we can do on our own environment. But for now, we will use that as part of the lab because it's provided in a given environment. But you can always try these things in, you can build your own environment and you can try all these things, but which will cost, right? Because once you start using your own infrastructure, it's like a matter is started. So for now, since we have the lab sessions already we have, so we can use that environment for testing and do that analysis once, and then we can take it after this training. Anyway, we can build our own environment and we can try specific use cases, whatever we like. Okay. So any other questions? I mean, I will leave like maybe next 4 or 5 minutes to discuss any specific open questions or anything that on the use cases or the technologies or anything that we talked so far. And then right at another 3 or 4 minutes, then I'll jump into the lab. Think of if you need to by the way, did I, yeah, it's broadcasting, right? So I can have a recording of it. So this is the case study I want to start doing. Let's see. I think this has some, it will use some credits, but let's do. I think let's do together, and let's make it more of interactive, this lab, than doing on your own. Okay, because I want you to understand the need of this use case and do it like a more interactive one, like we can discuss and keep doing in parallel. because you need to understand not only just doing step by step the lab or a use case, but why you are doing that use case has to be thought through. Okay, I want to have that experience here for you guys, so that will be more useful because these are like, knowing one thing, and technology, you might know how to do some, each piece of it, but now it's like clubbing everything and whatever you learned so far, how to apply it for a use case.
Castro garu, I'm sorry, I did not join previous classes. So for some reasons and other busy issues. So I'm going to go through the starting tomorrow. I'm going over all the classes.
Definitely, sir. Yeah,
the classes. One thing I want to understand during these classes, during the sessions, we covered how to use the DynamoDB, how to use the Kinesis, how to use the Redshift. We covered all those examples.
Yes, yeah, everything. Actually, we went through. So basically, what we know how to use Lambda functions, and we know how to use DynamoDB. We know how to use Amazon EMR. We know how to use Kinesis streams, and we know how to use Firehose, and we know how to use even AWS IoT, which we actually did, physically controlling the temperature, home temperature, using a simulated application. And we know how to use Redshift, and we know how to use machine learning, Amazon machine learning.
What did you learn? What did you do in machine learning?
So we used specific libraries. Basically, in the Amazon machine learning, there are few libraries we experimented how to use those in the machine learning topic. How you let me recollect.
No, I think I can go through the class.
No. Actually, there's a specific use case given. How we what is that? I'm trying to recollect the word. Anyone remember actually, guys? In the machine learning, the analysis that we did to what is that?
Flights database?
No.
Citizen flight.
No, flights only, but the end income. What is the prediction we did using that? It was predicting the delays, right?
Delays or traffic? What is the customer traffic?
Delays.
Flight delays, forecasting or predicting the flight delays.
Depending upon the city we select.
On the geographical location, if you click on some location, you'll be able to predict. Depends on number of departures it has from that city, and the projected delays or predicted delays. So that's a kind of, we are going to do something very similar, not the similar data set, but in a different context. Actually, today, whatever we are going to do also, we'll touch that to some extent. Okay, so it's a little bit advanced than the use case that we did. Actually, this is like a step forward on the same use case, what we are going to build today.
Thank you.
Okay, yeah. So, but nothing is difficult in these scenarios, because see, once you are given instructions, it's all easy to do. What my sincere advice to anyone and who are learning all this right now, think whenever you're doing is easy when somebody instruct, right, or somebody clearly tell you what to do. Make a habit of thinking that, okay, I have to do this in real scenario. Your thought process has to start. Like, nobody will give you instruction, right? So if you get that into that mode, that's when you're getting experienced automatically. So, but obviously you cannot run before walk, right? So you have to do stops what we can walk right now. That's why we're going in this space. But the next step is immediately you should be able to these all to get you more familiarity with all the stuff, right? First of all, a lot of technology is new for you, so getting to one stage is helping this course, but the next steps is like you can do a lot once you get the hold of it.
Yeah. Keshav, actually, Redshift the departure అది అండి. Machine learning the customer satisfaction, depending upon the age group and all.
But in the machine learning, where what we did is it traffic delays or is it remember some prediction?
Restaurant.
Oh, you're right. Sorry. Yeah, that's a totally different scenario. Yeah. So we did the Redshift one. Is that? Yeah, you're right.
Yeah,
So,
Redshift నేను చేస్తాను.
yeah. So this one, sorry. Thanks for correction. The machine learning that exercise what we did is it is like a prediction of like, will I go for this restaurant based on the basically let's say based on that we trained some data set. Basically we took some data set as a training data set, and then we trained the system to be able to predict if you provide an input later on saying that am I going to like this restaurant, it's going to predict for you based on the data we train. That's the use case we did. Yeah, thanks for reminding. That's good. Yeah. And now today, what we are going to do is much more related to the. I think this is where I think that's why I confused. This use case will get you to the flight delay stuff. I think using Amazon machine learning as well as Redshift together. Okay. So let's see. Okay, before because we have a limited time, so let me see. We can actually let me ping this for all of you. So look for that advanced Amazon Redshift analytics here in catalog. And again, since this is also given as part of instructions, it's easy to do. But at least this lab I wanted to do because so far you're able to do on your own. But I don't know how much of we are not having enough discussion on what you learned about that lab. But I'm hoping you all trying to pay attention to what you're learning. But this one at least I wanted to go through that together interactively. In that way we can actually talk about it and understand more thoroughly. Because this is kind of imagine that this is the type of scenario you have to address as a real-time use case for your client. So far whatever you did is not different from this, but this is the additional piece I want to put into this lab. How you think has to happen here, because after this you have to start working on the use cases that whoever gives tomorrow might give you some use case saying, okay, I need to achieve this. This is my use case. So that means we have to start working towards that with our knowledge, right? Okay, this was in the quest, that's why. Okay, so you will find this as part of the quest. Actually, in the quests you go to big data on AWS, not the beginner one. There is a experienced one, big data on AWS, use case experienced. If you go here, quest, in fact, this is one other thing I suggested to everyone. After this session's completed, feel free to go into at least 2 quests, which are, one is big data on AWS, which is a beginner one. And a couple of them already we might have done in this, but any other things left also you can do. And big data on AWS use case experienced. Doing these things will give you some more additional exercise practice to get you more, and also it helps you to finish the quests related to big data on AWS. So it is helpful for your training certification. Okay, so I would suggest definitely do that, and encourage to do. Okay, So again, you can do enrollment into Quest and do that offline, because you have to go through multiple things. But let's start with straight this. Oh, what happened? This lab is not there right now. Sure. Same problem happened. Other things are there, but not. It is there, but it is not available
You
currently.
have enough credits? You don't have enough credits?
No, it's not credits. Credits is 15. I mean, we
No,
have
and
enough credits.
it's under maintenance, so it might come
So
up.
problem
after
is,
the
yeah, so they generally what they say, this is like,
I
sorry,
see.
this lab is temporarily offline for maintenance. So they'll put back, but we have to wait for this. Oh, man. Usually some of these things, they go through regular maintenance sometimes. So they'll keep some of them offline and put it back again after few hours or few. So maybe you have to wait for this then, unfortunately. But this is a good case. I'll tell you, let me walk through at least the use case, what you are trying to do, which, I mean, I don't see any problem in doing this yourself also, but I want to think through this use case because I like this as one of the advanced one that will cover pretty much what you want to achieve using the platform. You will build a smart solution using the Amazon Redshift and Amazon machine learning that predicts the delays. Yeah, this is the one actually I was talking. It predicts the delays for flights originating in Chicago International Airport. This is a real live case. Using this data, you can really predict and tell what flights are delaying. This is the real data. Okay, you will learn how to analyze large amounts of data using Redshift. Then you will practice using machine learning to create a model that will predict flight delays. The prerequisites for this to completely this lab, you should be familiar with Redshift, which already we did, and some knowledge of SQL and Python programming. Although full solution code is provided, you need to know what is given in the code. That is what I was talking. See, just because they gave you SQL and Python, it doesn't mean like for every use case somebody will give you. You got to know what type of things to be achieved by looking at that code more thoroughly. You should be comfortable using RDP, which is basically remote connection to any Windows server, which you do in most of the organizations already. So, and that's pretty much. I mean, you already covered basics of Redshift and machine learning, so it shouldn't be that bad. But when you really start doing this exercise with the context of what you're trying to analyze and understand, it'll be interesting, the use case, because if I know what flights are going from Chicago airport, and if I can predict what flights are going to be delayed based on the history, right? If I can predict, that means I have enough information to forecast something, which is very useful for people who are traveling in the consulting business actually, especially if you are going to Chicago. If you know this data, so you can plan accordingly. Depends on delays ahead. But yeah, I mean, having said that, right now, since we don't have that, I mean, all other things are like independent things.
Can we cover anything machine learning, model building, and training the model? Sorry, creating a model and training the machine learning to.
Yeah, I mean, that's what we
learn
did in
from.
the. Let me do a quick recap of it. Maybe that will tell you how. Maybe I think at least for Om and also for others, right? It will give you some understanding of.
The nice results there. Nag, are you there?
Yeah,
Yeah, I'm here.
yeah. So let me quickly recap of ML,
No,
which is
but
because of coding
if
stuff.
you have anything, it may be repetitive for others. If you have
Yeah,
anything, please go
it'll
ahead.
be a little bit of repeat, but it'll be useful. Yeah, definitely. I feel this is a topic that would be more beneficial for everyone to even recap. But if any questions for anyone, you can feel free to ask. But otherwise, yeah, we can definitely use the time of this one to just quickly go through some of these inputs that I already gave. But with your contribution, Woman Nagesh also here, it'll be more productive also for others also, because they don't have much questions. It's like a one-sided one way when I explain some of this stuff. But since you have some background with this, it'll be more interesting discussion for others to listen in as well. Okay, so let's go through quickly. I kind of explained the definitions of it, what is and all, what is machine learning and all. But primarily I was explaining them the biggest difference between the what is the traditional programming to machine learning. This is the biggest difference in a simple way. In the traditional programming, we give data and we give program and we expect computer to give the output. But in case of machine learning, we give the data and we also provide the output expected. Basically, we expect the output and computer should produce the model, just program. Okay, so this is a different way of looking at how traditional programming to machine learning programming. And this is another analogy to compare with gardening of the programming, traditional programming. Traditional programming is like gardening, right? So you need seeds, which needs basically algorithms. In the analogy that if you want to compare, nutrients are like data. The gardener is like you, and you need plants to grow because. So this is like it's not like any more gardening because traditional programming is like gardening, right? You need seeds, nutrients, gardener, plants. But now to grow the plants, you need you don't need
Seeds,
to,
nutrients,
basic,
nutrients and seeds are needed.
all you need is correct. You need the algorithm, you need the data. You don't need yourself. You want to be out of this business.
Yeah.
You don't need to be a gardener. Let machine take care of it.
Yeah. Basically, you're creating a new brain. Artificial intelligence is
That's it.
creating
So basically,
part of the brain, replicating part of the brain.
that's it. So let the machine take care of it, and you just basically basically it's a replacement. Artificial intelligence.
Yeah, human replacement, human brain replacement, human brain replacement. The human brain that is doing the driving and that is doing how to drive,
right.
how to drive and how to stop and how to not stop.
Right. Yeah, it's kind of artificial. That's what I showed in the first slide. Actually, what is machine learning, right? Automating automation. They're getting computers to program themselves. Writing software is the bottleneck. Let the data do the work instead. So that's the kind of definitions, because this will give you in a simple terms to understand, people who are new to machine learning. It gives a better idea. So in some of the sample applications we talked about, what kind of things can be done. With web search, computational biology, finance, anything is nothing is exception. You can create artificial intelligence use cases for any type of scenario, and we went through what are there's so many machine learning algorithms that could happen every year. They keep on generating, and so many things are happening. But for any machine learning, they have three components: representation, evaluation, optimization. You keep doing optimization. No model is perfect. The example that I was explaining to when you put some message on earlier, why stock prediction is one of the most difficult thing, because see the entire machine learning model itself, I represent it, evaluate it, optimize it. That optimization part is so dynamic in the stock market. Most of the time like that only, a lot of use cases, but in this case it's much more dynamic and with the parameters that are not in your control, a lot of external factors. That's why it's a continuous process and no model is perfect for stock, at least for stock prediction. Okay, and I went through some of these low-level details. We don't need to, I think, get into that. But and again, I talked about what all the various types of learning: supervised learning and unsupervised learning, semi-supervised, reinforcement. So these are supervised and unsupervised are mostly. Depends on situation, right? When you have enough training data, you would be able to provide, include that as a supervised learning. But sometimes you may not have enough training data, so you may go for unsupervised learning. And if you are not able to recognize them, right? Especially with unstructured data, most of the time you may not be able to recognize what type of data it is. If you are able to recognize easily, you can go with supervised learning. And Yeah, so this is the loop. If you see what is in practice, right? This is what we're talking about. It's a continuous loop. Understand the domain, prior knowledge and goals, the data integration, selection, cleaning, pre-processing, learning models, which is with the training data, interpret the results, consolidate and deploy discovered knowledge as a model that can predict for you, but loop it again because it's not going to stop there. You have to again understand any changes, variation coming in the data inputs. It may not be able to predict as you modeled it. So it has to continuously learn. So learning is based on some training, but that learning could change based on new inputs, and it's continuous process, the loop. And this is a standard DAG execution plan as part of the machine learning pipeline. Very standard way of looking at what is machine learning pipeline and in theory.
Keshugaran.
Yeah. Hello?
Yeah, Keshugaran.
Yeah.
So if I may add just a point here. So in real world, most of the time, is actually spent in the first two bullets, the first two steps, understanding the domain, prior knowledge and goals, data integration, selection, everything, that's 80% of the time. 20% of the time is in the learning models.
That's correct. Yeah, that's correct.
Yeah, what we are trying to do now is with the new, the big data and technologies and integration, new methods to, speed up the data governance and automate some of the process, that's where you're trying to cut down, in the 80% of the time, if I may. So.
Yeah, that's true. That's a very good comment. Yeah, that's true. So yeah, I mean that's what ML is like. The way I feel, most of the people look at ML. Sometimes I seen it, at least in my experience, like in my previous company. I think you know this. I was talking about some predictive model that we built for my logistics company when I worked on. I have seen people who had a mindset of, okay, I created this model, it should work and I should get the accuracy predictions, and which is the expectation itself is wrong. I try to explain that lot to. They're not like some junior people. They're like really real data scientists and with a lot of knowledge and experience. But still, the mindset of thinking, they were always in the model. Oh, I created this model; they should predict very well, and why my forecast is still not accurate. And in the machine learning, what I learned is your forecast can be never be 100%. If it is, you're not really dealing with the real use cases. I mean, the data sets, because there is always a prediction, always going to be maybe like 90% accuracy, but it is always going to change. That's what, because machine can learn. It's not a static thing. Learning can happen even like a human, right? We learn something. Till today, if I know that whatever I learned is the best and that's what it is, and I make my decision based on that, that means you're not considering any new input and not adjusting your intelligence to make a different way of decision. That is what human brain do. And if machine learning model is not adapting that as an expectation, that means that model is not really close, not anything close to brain. So I know that's something like depends on users. Some people have very clear understanding on what it should be, but some users will have some such expectations. So it's better to discuss those upfront. If you see such users. Okay, this pipeline is just to give an idea how generally there are two paths, right? Training path and testing path. So whenever you get some data available for you, never ever use all the 100% data to train the machine, because if you train with all your 100% data, you have no data to test whether it is working or not, your model. So you should be generally going with like 70% of data for training purpose, 30% for validating it, like use it for testing data. So that way, otherwise, how do you know if you train all your data for use it for training, then there is no input that you can validate, because to validate, you need to have some fact. Let's say if you have a data set that has some results already, something happened in the past, so then you have to validate, right? Like by giving this input, if this is the result came in the past, that means it is working as per my expectation. My model is working as my, so that you need that 30% or 20% of data left for your testing purpose. Okay, so that's what kind of explains here. It doesn't tell the percentage here, but the path, there will be two paths for a pipeline, and training data and testing data. And the training data has to go through model step, and save the model, check the results, use it for predicting and label them, and basically recognizing the data, like, okay, this data belongs to, because it's like this, or because it's all these are red, so this goes into red category. All these are circles, it goes into circle category, something like that. Categorizing objects, or separating them into labeling them. And then you can create metrics out of it, and then save metrics. And same thing happens using the test data also in the pipeline. But first one is to help create the model and use that model for validate. So this is how it goes, right? I mean, again, the model, give input samples, let the system train, get the train, and let the learning methods model created. And then when next time input samples comes as a test data, let it go through this and let the results predict. So we kind of gave some examples here, like how the training set and testing set, observed, unobserved. These are some of the examples shown to physically see how things happen. And we talked about the modeling and optimization stuff, algorithms. What else we learned here? So provide some examples given here. And yeah, this is another thing that I was talking about. Some of the algorithms, how supervised, unsupervised, and semi-unsupervised, right? If this example, if you understand it better, see some of these objects here in the supervised learning, you could clearly label them and identify them and label them as different buckets clearly. All these red circles are in one category. All this star, this color is in one category. It's easy to categorize and label them because you have a clear labeling for this data. So when you have clear labeling and easy to recognize, it will go on to supervised learning path. And if you don't have, so let's say everything is blue circles, and there is no way I can separate them here, at least by, if I want to go by color or circle characteristics like features of this object, no way I can separate them. Only way I can separate here is by location. Okay, all this clustered into one small group, so I would consider all of them as one category because I don't know what that category is, because they're all here in this one location. They are spread a little bit here and here, 3 groups. So let me take this group as one category, this group as one category. So because you don't have anything to supervise here, you cannot tell, because all of these are same almost. How do you separate them? Right, that's the type of scenario you go for unsupervised. And this is a semi-supervised. So when you look at some of these objects, these are, if you see here, wherever you can identify and label them, you identify them. Already you identified, right? This is a mixed actually. So it is a supervised, semi-supervised means it's supervised as well as unsupervised in 2 different ways, right? So why it is supervised, we are calling it as supervised here, because you're able to, at least objects wise, you're able to say, okay, anything square and red, put into here, anything square and star, put it here, anything square and plus, put it here. But when I say that as a supervised learning model, I see square is coming in all places. So still it is not properly categorized. So there should be a second way of looking at that. That second way is, okay, everything is in this area, this clustered, an unsupervised model. Okay, we'll go into one bucket. So that is where you are mixing both. That's why it's called semi-supervised. Okay. So yeah, so we looked at this, some of these, how the actual mechanics, how it will get the training data, documents, images, or whatever coming, how it identifies the features and vectors, and go to mission algorithm, and we generally basically when we find that, we find them and label it and recognize them, and goes to predictive model, and then a new test data coming, and it will identify that feature vector and let the predictive model expect the label. So it's basically very similar things, supervised and unsupervised wise. So what are we seeking? And these are some mathematical functions we looked at, and though as I told again, I mean, though I'm not a math PhD or whatever, but some of these things I really don't have a clue of what this exactly doing this formula, but these are all like standard formulas or functions. I would simply use it because somebody else tell this works this way. So, but if you are into a little bit of deep math, this will actually help you to find some new functions, or maybe the functions, how to use that function in what context. You'll have much more deeper understanding that will help for your data science skills as a whole.
Nice. What is this 1 by n sigma of 1 and 2n? We have yn not equal to g of xn. What is g? Oh, g is defined here.
Yeah.
E out
So
of g equal to e less than of g.
G is, I think, in this case, I think global, right? Global or?
No. Okay, that's fine.
Yeah. So, but here in
we'll try to understand more.
The most important thing to understand in this context is output and input error. Basically, your E in, right? Your E in is like a for training set, E out for testing set. And when you do this deviation, right? I mean, E out should be always less than E in. What that means, your training set error factor, right? Your error factor in your training set, your error factor in your testing data set should be less than always or equal to the error factor of your training set. If it is the other way, your model is useless.
Input set, right? Input set or training set? Okay, input.
No. Training and testing. Look at that way. So let's say I take 70% data I have, 70% data I took it as a training data set to learn my machine, right? To teach my machine, right? And then it learned and it understood some experience and knowledge, and then my model can start working if I get some input. So I have to test that, right? So that means I have to test with the real data that happened already. So I take the 30% of data as a testing data, and now I give that input and see what really it is predicting my model, and if it is matching with my result already happened in the data set, so then I can compare my error deviation, right? How much of that's out of 30% of data I'm giving. Let's say everything is going wrong, my prediction, right? And the percentage of that error in testing data. Let's say in the 30% data, my error factor is 70%, 50% or 60% is errors. That means it's not predicting as expected, right? And let's say when I do my training data set, my error factor is only like 10%. That means my model is, I'm thinking that just because of the training data I put in, and my model is like working perfectly, and I think that, oh, it's only 10% error, I can take that as an exception. So my model is perfect, and now I deploy my model and expect that my model should work perfectly for any input I provide, and then I started testing with my 30% testing data, and then my error factor is coming like 50%, 60%. That means my model is not working the way I expect, right? So that is what the important thing to understand here. So it should be low E out. That means maximize the probabilistic terms. Your E out should be very low. E out is for the testing data set. Whatever the error factor for the testing data set should be very low. Then your model is working best. I think I hope that makes sense, right? Do you guys understand what, right?
Yeah, it makes sense. Basically, what he's saying is the data set you are giving, the error, in the training data set is the output you're getting should be, it should not be, error should not be less. Basically, 80% should be accurate.
Yeah, it doesn't need to be 100%, but at least should be, it should be as much as accurate possible. That's what your accuracy factor is, right? So
let's
error
say that
factor
100% results out of that data set. 70% should be accurate, and 30% can go wrong. Maybe.
Yeah, I mean, yeah, no. Again, 70%, 30% I divided for the data set itself. What data I have with me in the history, right? And I divided that data set as 70%, 30%. 70% to use it for training the machine, and 30% is to test the model that I create out of the training data, right? So, but now within the 30% of data, when I start testing that 30% of data, my accuracy of the prediction, let's say it's 60%, right? That means it's okay. It doesn't need to be 100%, but whatever that accuracy it is doing, the 60% of accuracy of my prediction, it should be at least bigger than my success ratio of training data set. When I created my model, if I am happy with the 60% of accuracy with my training data, and then I created that model and let the model work for my training testing data, and if my testing data also giving me around 60%, I'm okay. But when I build my model with the training data, and I see in my training data set giving me 90% result set accuracy, 90% accuracy, then I thought this will work for 90% of the time, and I created my model and now expect to do some predictions based on the testing data, and those predictions are not coming as 90% accuracy. It's coming as, let's say, 30%, 50%, or whatever, right? Then that means it's not performing as expected.
Yeah, we got the point now.
Yeah, so that's the important point to catch, because your aim is always to have a low E out. That's our goal. When you are testing with using your testing data set, whatever the error factor happening in your accuracy, it should be as low as possible. Then your accuracy is high. And that's what these formulas are really, I mean, the way blindly I understand these things, this is the error factor for testing data set. This is the error factor for training data set. This is kind of a deviation formula, basically to some standard deviation formula. Yeah, because mostly, standard deviations comes for the likelihood estimations, right? So that's what they use here. This is what another important learning that we had in the machine learning, and most people don't look at this as an important thing, but it's very, very important factor. When we create and train the machine with some testing data, training data, and let's say I use my 70% of data to create a model, and I'm satisfied with the results it is producing, and then I created a model and let it test with the remaining set of data. And when I'm doing, this is where the error graph, if you see the deviation and error graphs and E in, E out, all right. If you see anything in this zone, that means it is underfitting. Anything you see on the other side, it's overfitting. This is where at least you have a balance. When you're preparing the model, see, it is an iterative process. At what point you will decide my model is working best? There is no bulletproof answer for that, right? You are training the machine, and at what point you will satisfy saying that, okay, now this model looks good to me, this can predict good enough with accurate results in the future. When do you get that feeling is based on your judgment, right? You have to decide my model will work now, and to decide that factor, you have to know whether your model, when you're training the data, when you're training the model, is it underfitting or is it overfitting? Your decision has to be at this level. That means with any type of data set coming, if it is falling in this zone, that's the right point of judgment. You can consider that as a good model and let it predict from that point.
Yeah, E in and E out is closer to equal to or less than or equal to.
Exactly. If it is equal, you're perfect. But at least close to that. That's exactly the point. That's this is kind of a version that I am explaining from the formula to in the more visual way. That's, okay, so these words you will hear very frequently. Is your model underfitting or overfitting? How do you decide your model is the best? For the best predictions or accuracy results. So there is no bulletproof solution, but it's just come by experience and visualizing yourself where your model fits in based on the data sets.
Basically, the diverging, right? Currently,
Divergence.
Divergence is more in the beginning or end, whereas the center, the divergence is the converging.
Yeah, this is a convergence. Yeah.
Convergence is the converging. So more
you have to find the converging point. Yeah. And that is when you can feel confident about your model. And okay, but this convergence, whatever you identify, that is limited, or your judgment is good only based on the data sets you tested and verified. And that verification has to happen continuously, because as the more data, let's say today I have only 10 years of data and I created a model based on that prediction, that historical data. And in the future, let's say after 1 more year, my data set may be totally different because of history changed, right? So your model may not be best fit at that point. It has to continuously refine. That capability has to be built in to learn, continuously learn and adjust your model. So yeah, these are all various techniques we talked about, k-nearest neighbor, all these are very standard things, you can find in any, standard ML documentation. But as people learn more deep dive into these things, you will get it. But when it comes to some of these learning techniques and methods, first of all, you need to understand the concepts better. Then it's all about working with some of the existing machine learning libraries and functions. And that's what you will learn. This is another good example I was explaining to the other day. See, if you know your training data set is giving you error rate 0.10, okay, and if your testing data giving the error rate of 0.156, for example, okay, this is one algorithm is giving this type of result for you. Okay, now look at closely. This one is training 1.10, testing 0.156. The next one is training 0.11, testing 0.145. Difference is the first one, training error rate is smaller, testing error rate is higher. The second, training error rate is higher, testing error rate is smaller. So which model you would prefer as a data scientist?
No, they both are same, right? No. So the second set testing is greater than training.
No. See, think of this. First scenario is this. Training data set error rate is 0.10. Okay, and the testing data set error rate is 0.156.
So testing is more error. Testing data has more error.
Testing has more, correct, here in this case, right? More, and also it's the same data set. Same data set you're using, but you're using a different algorithm. Okay, one algorithm is giving this type of results for training and testing. Okay.
Okay, the difference is very high. The training and testing error rate is
exactly that is the difference. That is the point you want to catch. Yeah. So here, the difference of training and testing is high here compared to. Not only that, actually, there is one more input here. See, in this case, your training error rate is 0.11. Okay, which is a little. See, if you see only training data, and the percentage, which error rate is higher, the first one or second one? The second one is higher.
Yeah.
Right. In the testing data set, if you see the error rate, first one is higher, second one is lower.
No, second one is also higher.
No, not higher than the first one.
No, yeah, I agree.
I'm comparing within the testing data result.
Within the testing data, yeah.
Within the testing data, which the first one is the higher, second one is the lower. And within the training data, first one is the lower, second one is the higher, right? So if you see, generally, the choice, see, the data is same, but one model is giving you one result, one error rate for training and testing, and the other one is giving different error rates, right? So naturally, what you would pick up for a better model? Which algorithm you use for your model? The one that is giving you less error rate in the testing data, which is second one.
Okay.
Though it is your training. See, when you are building a model, when you're teaching a machine to learn based on your training data, right? And you might feel, oh, I'm training this machine, but the error rate is like 0.11. It is a little bit higher compared to the first one, right? If you simply depend on your training data and feel that, oh, my error rate is less in the first case, and you're wrong. That is not the decision factor for you. When you're training the system, it may give you error rate. You should not feel that, oh, I'm getting less error rate here, so this is good. You should not feel that, because you're training the system. Just because when you're training, it is giving you less error rate, that is not the best model. Because your testing is the driver. When you're testing, what model is giving you less error rate, that is you should give higher consideration for that model, for that algorithm. Does it make sense or no? If you want, get the point, right? Because you have to have a proper understanding on why you are picking one algorithm versus other algorithm. When you're because the error rates are critical to make a decision. Okay, so yeah, I mean, if you talk about, right, I mean, there's a lot of detailed stuff, in everywhere you go. In a lot of forums and blogs, and you find a lot, actually. Actually, you are the best person on some of this stuff. Really, I see some of your blogs and all that you send. It's really interesting. When I go through, I mean, whenever I get time to see, I'll try to look at some of the stuff, and I do have a lot of such forum blogs type of things. But everything is very interesting. Any particular thing you take, it's very interesting. And especially when you connect that with the use cases that are happening outside, like what type of applications, what type of advantage people are taking using those algorithms and using that scenarios, it's really fascinating. Even see some of the applications that we generally use, right? I mean, these are all like very real-time scenarios. You can use it for face detection. Suppose New York City may be doing so much face detection with so much tons of images captured in so many cameras and sensors all over the city. And the face detection is one of the biggest thing for New York City, based on so many images in their database, tons of them. The object detection and recognition, and image segmentation, multimedia event detection, and economical and commercial research, sentiment analysis of source. So a lot of this stuff, right? So this is one analysis that we looked at, how Amazon AWS can, this is one type of architecture that we looked at. But this is for sentiment analysis of social media. But again, this architecture is not the only architecture. And in this case, you could actually replace the S3 with Amazon EMR here, or the solutions could be so many. Okay, what you use, it's up to your needs. Yeah, I think that's what I mean. Pretty much like we tried to cover all the basic stuff, and then we did some a nice lab on that. That way, we were able to experience that. It's pretty much. I mean, again, as I told, as much as you understand the fundamentals and you practice some of the use cases, even if you learn one or two use cases, that will give you enormous experience.
Yeah.
Okay, so definitely don't miss out to do this whatever the assignment I ping now. I hope it will come back maybe in a day or two, whatever, because sometimes this maintenance, last time it took it took a day or so, 2 days I think. Sometimes but keep an eye, because you have an account with credit. You can always feel free to do not only the labs I am telling you, right? because these are all the reason why I asked you to sign up on this one, because I don't want you to limit only what I am teaching, because this is a starting point for all of you, and you should be able to continuously focusing on this, because if you want to make this as your career, or use this for some specific projects or whatever, uh, a lot to learn here. If you see, there is nothing wrong even learning all of this if you have time and enough energy to do these things. Nothing is everything is going to be somehow useful, if you want to stick on to AWS platform for your solutions. But if your focus is only big data platforms, doesn't matter whether it is AWS or something else, then you don't need to spend too much time on the AWS side. But at least my intention and my suggestion to a lot of people and customers to use Amazon as the solution, because your solutions should not be limited just based on some though it is a Hadoop, this is also Hadoop system, right? I mean, with Amazon EMR you have that, but don't limit your solution options only to specific technology or specific tools, and let it be more based on value add solution to your business, especially if it is a startup companies and all the new products and all the stuff. There is no need for us to use standard solutions. You can, because you don't have any baggage to convert something like an existing system, existing data and all that. So when you are building something new, Amazon is the cleanest slate to start, and more cost effective and more efficient as well. But when you have something like, suppose I'm working at Verizon right now, though I know Amazon is the best solution, we are not doing Amazon EMR as our solution, but we are using Hortonworks. The reason for that, there is a lot of factors. There is a baggage, because there are so many data sets that are already sitting in on-premise, which we cannot move it to cloud at this point because of so many regulations and other compliance or whatever other reasons. At the same time, even if we wanted to do, so much logic migration has to happen and data migration has to happen, and instead they had this all in on-premise, and they're doing anything new that we're building or something we're setting up, we're going to the AWS cloud strategy. Maybe for example, non-prod environments, we are going to Amazon, and then keeping something secured or something more sensitive on-premise. So we are kind of having in a mixed, because of the baggage, because company and organizations like that, any big companies, they have so much baggage to think through and go ahead. But when you are building something new completely, you have nothing to lose. You're just starting fresh, right? So you don't need to migrate or anything. So whatever you bring newly, just bring it to this. So then your solution is much clean. You're starting off with a best platform. So that's why I kind of lean to when Om told me some use cases they want to work. I thought, I mean, if I want to do on my own, I would do the same. That's what exactly I am suggesting to Om and Nareshwar also.
So,
Okay.
Keshavarani, so if I may add just one thing here, I know we have a team that has a very diverse background. Not everyone has to get into modeling and analysis and all that stuff if that's not your cup of tea, right? So you just need to understand what your interests are and where you want to be. So what I'm trying to say is, within the big data, there are flavors of roles, without getting into modeling and all that stuff.
That's true. Yeah.
I think the information that you shared and the training that you gave is actually more oriented and geared towards getting you into the data scientist kind of a mindset.
Correct.
Versus a big data framework, technology, that kind of roles. Let me know if I'm, please keep me straight.
Right. Yeah. Basically, my intention of this one is to make more of get you awareness on various big data solutions. Big data solutions.
Absolutely.
Yeah. Because the way I'm looking at this course, to enable any person who is interested in analytics space or big data analytics space, and not only limit their capability or options to only big data analytics, and they should be knowing the other side of big data analytics on AWS will enable them to what other additional things that can add value to the business. So
And to your point, with all the latest tools and the technologies that we have,
Right.
the model building and everything became a bit more easier than what it used to be.
Exactly.
So
100%.
earlier,
100%. Yeah.
folks used to spend a lot more time on the model building. You had to
Yeah.
go all the way into the model cleaning, variable transformation, and everything,
Yeah. Yeah.
and variable selection, distribution checking,
Right.
assumption validations, and all that stuff.
Right.
Now with the click of a button, some of these tools that we have today, everything is done for you. So
Exactly. I think more and more technology is eliminating the need of everyone knowing the
yeah,
bolts and nuts of
everything.
every
Yeah.
technology,
Mhm.
because they want people to focus on the value addition for business than
Mhm.
what exactly, because there's a lot to happen. Actually, this is a good concept in my view also, because more time we spend on technology and all this technical stuff, but finally
Mhm.
what is the outcome business is getting out of it, right? Less focus or less time spent on that, and finally they spend millions of dollars on the platforms and technologies and all. At the end, what business get benefit out of it, still in a question, because of all these complexities. And rather the tools and technologies are really minimizing all that. Basically it's gearing towards, mostly like as you told earlier rightly, it's all trying to put the people time and efforts towards more data science and analysis of data itself, and finding business insights and adding value to the business. Than not everyone need to just, even any business analyst can actually do a lot of this stuff because of click button type of things, right? So they're making more into that type of things, and slowly it is kind of converging technical skills, business skills, and operation skills. DevOps business, basically. A lot of people call DevOps, but I'm calling DevOps business, because even in my one of the seminar, I was telling that DevOps is an old term. DevOps doesn't work. DevOps, business DevOps actually, biz DevOps, because if DevOps collaborated, you might avoid a lot of collaboration is well help to minimize unnecessary redundancies, and a lot of uh, work delays and all that, time to delivery. But a lot of stuff, there is a lot of gap between business requirement to the development teams, IT teams. There should be a lot of collaboration between business and IT, and within the IT, between development and operations. And the walls should be broken out. All the walls between business to IT and IT within IT, everything has to be broken. Otherwise, no value to business, and at least not time to market. You can give a solution, but 1 year you take with all these complexities. But once you break that, you are getting the value in a split second, right away. So I mean that's the direction I see it more and more trending right now. I mean, if you go with any agile approach, a DevOps approach, and all this, but still they're like, in my view, there are still some silos. So yeah, I mean, a lot of this stuff, making technologist as business person as technologist, operation person as developer as operations, so like infrastructure. So yeah, so we have to, I think very soon there is no difference between any. That's why people are calling now data engineers, data scientists, and all this. There are no more developers and DBAs and all that type of things.
Yeah. So to give a little bit more tangible, right? So there are statisticians, applied statisticians, market analysis, and on that roles. And there used to be all the IT roles who used to take care of the data warehousing,
Right.
maintenance, data loads, and all that stuff, right?
Right.
So those are various, two distinct roles back in the day.
Right. Right.
Now these two are coming very, very, very close.
Very
The
close. Yeah.
roles
Very
kind of
close. Yeah.
data science, and in a way, like you said, Keshav, the wall between the IT
Yeah.
and the
Business.
business
Yeah.
analytics function is broken out.
Broken out. Yeah. It
Yeah.
has to be. I mean, the value can only come out for analytics by breaking that. That's the only way. Otherwise, one of the things will miss. Either they cannot deliver it to the time to the market, it will be delayed, or it will not be delivered with the expected results or expected requirements because of the wall. Yeah. So anyway, so any other questions from anyone? I mean, I kind of time to wrap up for me, but
Sir, I think, Keshav, maybe we should do one exercise tomorrow. I think tomorrow or whenever the lab is available.
Yeah. No, actually, my suggestion, Andy, you should be able to do, and we can definitely gather if there is a need. But I never seen so far anybody, even the new people, like there is and all these guys new completely have any struggle or any issues with the lab. It's so clearly given. But my feeling is you can do on your own time, as needed. But definitely, if there are questions, we can have a one session to quickly gather and discuss any issues or any problems. But I don't know. It depends on everyone's time and availability as well, right? So, but I'm definitely available and open anytime. You want to give a call or or talk separately, also fine. I don't have any reservation on that. But if it is a need, definitely we can do. But
Okay, that's fine. Thank you.
no problem, sir. Yeah.
Okay, so I think you remember you want to cover the big data,
Certification, right?
certification.
Yeah. Let me quickly go through. That's a good point. Actually, I will send
the details. You can go to.
Yeah.
If you're running out of time, you can go.
No, that's okay. Actually, it's a very quick thing. Actually, I'll quickly go through that once because it actually I am also doing that right now. Actually, the preparation are happening for me because I am trying to finish my AWS solution architecture certification. It's a mandatory for me in my office. Unfortunately, I never did. I did solutions, but I never did certification. So they're asking now.
Do they pay the money?
Yeah, they do everything. They pay already. They want. It's mandatory for our because they're big time in AWS right now for our group. And if somebody don't know, they don't want to say that I know or I don't know. They want just certification, simply mandatory. That's it. Amazon AWS training, not training, certification. There is a clear path actually given. I will show you. I have a web link. Oh yeah, here it is. Yeah, prepare for certification. See, there are multiple sections here. Obviously training classes and all that you don't need to worry because suppose you are doing on AWS Architect. So they say recommend to take this course and all that. Again, you don't need to really, a lot of stuff you already covered as part of our learning itself. But if you want to do any additional things in the quest, you can do. But generally, main thing I would say certification target should be to review the exam guide and sample questions. There is a textbook also you can buy. I will send one link actually. I'm about to buy that, but that will be like a book actually. Somebody from Amazon, I think, published. That one thing, and then there are self-paced labs and some of these exam preparation quest also there separately. If you go here, they clearly put like suppose solution architect associate exam. They created a lab specifically for that. Like you can practice that itself, and then you can have a lot of white papers and all that there. So once you go through all that, then exam readiness workshop. This is what you may have to take. There is something called AWS certification exam readiness workshop. Okay, so this is like a 4 hours session which can be covered. But again, if you are very serious about certification, I would suggest to do all this. But otherwise, if your intention is to learn and do things but not certification, then don't worry too much. But generally it has some value in the market, especially because we're all learning for some career advancements, right? So it helps, especially with a small cost, right? The test also not that much. For test preparation it will be like $20. For test not preparation, for test like you can have a mock-up a test, like a mock test preparation type of thing. That will be like $20 cost, and the actual exam will be $150. That you have to schedule, and before you schedule, you have to prepare all these things first. Then you schedule, and you can actually go for the certification. That will be $150. So before you go, instead of paying $150 and failing, so you do enough practice. If you want, maybe do a couple of iterations with the test $20 thing, then you can actually take it, because that will be very close to real exams. So that's what I'm trying to do this month. My target is this month. So I'm just waiting for this training completion so I can spend some time on weekdays and
So
weekends.
in the exam, do they ask for a lot of theory questions or?
Yeah, that is the challenge, because more than your real experiences, though I have a lot of experience, I have to go through all this formally, because when you write exam, there are a lot of in theory you have to really have theoretical background as well, a little bit. So it's kind of a proper preparation we have to do.
Okay, thank you.
Yeah. So if you're serious about certification, definitely take proper preparation, because it's all clearly given. If you see here, if you go to AWS certification, they tell you all these where is that? Yeah. So but the path, what I want to show is actually the path. There are three paths. One is associate. Yeah, here it is. Is that? Yeah, there are three types here. See, associate, AWS certification types: associate, specialty, professional. There are three categories. Everyone, the associate is mandatory for any of this. You want to be in a specialty or professional, you want to get the certification. Without associate, they won't allow that. So everyone is mandatory to do associate. But again, associate also, there are three categories. See here, this is the best one to show you. The higher light, architecting, developing, and operations. Three categories. In architecting, you will call AWS Certified Solution Architect Associate. That's the first level. And in developer, you'll say AWS Certified Developer. That's what. In operations, you'll call AWS Certified SysOps Administrator. That's all these three are associates in each area. And then next level is once you finish associate, then you can become professional in that area, like solution architect or DevOps engineer. See, if you notice, both developer and operations will lead to DevOps engineer roles. The other one is more to solution architect roles. Okay, and you see the side thing, the specialty certifications. This is where our focus is, AWS Certified Big Data Specialty. Some people go for advanced networking specialty. That's more on the operations side and networking side stuff. But I think our focus should be on AWS Certified Big Data Specialty, because that's where our interest is. And because we are targeting for a specialty of AWS Certified Big Data, I would suggest to finish the AWS Certified Solution Architect with, of course, with the associate and professional. Associate is mandatory, professional is optional when you're doing specialty. So this is the various roles and paths that you have to go through. This is the roadmap. It's all available on the AWS training certification itself. Like you'll find you can schedule this. Also preparation site. Now I'll send some links actually. All with nice clear steps, which I am actually using as my reference. So I'll send those things, so that way clearly path what exactly step by step what you wanted to do.
Yeah, sir, can you put together all these training lessons in one email and send it to us?
Yeah, I'll send all the links and all the references in one email, so that you have it in one place. Everything you can.
Now we'll read it. We'll read it back again.
Yeah, so it's very important actually. Especially for the people not much experience, right? So it's very important. So most of the stuff when you listen and hear, it looks simple and easy, but it doesn't stick with the brain until unless you experience it, right? There's no replacement for that. So we have to repeat ourselves. Reading is the only way. Reading and that can simulate something like experience, at least, though it's not real experience. And especially a lot of these buzzwords and keywords, so much confusion will be there at later point if you don't repeat or review this more closely.
Sorry, Keshav, actually I got a question. Like,
Tell me.
so what is the certification you are going to take, and is that the associate or the professional?
No, I haven't done any AWS certification. So first, I am supposed to do this AWS Certified Big Data Specialty. That's my target, but I cannot do directly. I have to do associate.
Yeah,
then I can do that. So, but this itself, you have to do a lot of reading, because I mean, I have enough background for that, and a lot of stuff practically I can tell easily. But when it comes to the theory questions, you have to use exact wording sometimes. So that's why you have to read.
So you are planning for the month end, or?
I haven't scheduled. I mean, first I'm in the preparation path right now.
Okay.
So because it's a mandatory for me, like my senior management actually asked commitments from every resource and every person in the team. Especially for me, it is a bigger commitment because I'm the solution architect for my team. So first of all, I have no choice, and others can tell some reasons, but I cannot tell.
Wish you all the best, Andy.
Yeah. Thank you, Andy. Yeah, I never thought I would need to do certifications after all this experience. But, but I don't want to show them as like I'm an exception. So
Yeah, I know, Keshav and I know we missed, I missed a lot of classes too, like home, but thanks for sharing all the videos, video links. So, we'll do our best to catch up, and,
sure, Andy.
We'll stay in touch.
Yeah. Please, Andy. Yeah, please feel free to ask any questions or anything. Because obviously a lot of stuff will be more interesting, through the discussions. I know we missed a few of the sessions, but I was really hoping I could learn more from you guys when you joined. But I feel also I missed some of this from you. But we'll have anyway, we'll work through other things. Also have you also have some plans anyway. So hoping we'll work together more closely.
Thank you. Thanks a lot, Keshav, and very informative sessions and training. And I learned a lot about what is the Kinesis, what is the Lambda. I know from Lambda, I know, but not Kinesis. What is the Redshift? What is this?
Oh yeah.
What do you call that? S3. I know only EC2, and when we're setting up the environment, only I know EC2 and RDS.
Right.
Now RDS, EC3, K3, Redshift.
And especially Kinesis is one thing, Andy. I'm sure once you start really building your product or anything that you're trying to do now, you will see most beneficial out of Kinesis, in my view, because especially if you're planning for more real-time analytics,
streaming and everything. Yeah.
So which is you can achieve still with a lot of other solutions, but no one can beat AWS solution at this point on that.
Yeah, thank you.
All right, so I think past 10 minutes already. Took more than hopefully please stay in touch, and everyone else please I hope what I'll do is maybe I'll create also a Google group or something that to stay in touch, so that way you can keep posting your any questions or anything that not only me, right, any of us can post and learn from each other that way.
Good idea, Andy. Thank you, Andy.
Yeah.
Good night, everyone.
All right. Good night, everyone. Yeah.
Bye.
Thank you all. Yeah. Bye.
Yeah. Thank you, and good night.
Good night, sir. Yeah. Bye.
Yeah. Thanks, Keshav. Thanks for the class.
Thank you very much, Amma. Yeah. Bye.
Bye.